Your bones are made out of exploded stars. The supernova wasn't just calcium-rich, it was the richest of the rich. According to new research, half the calcium in our universe came from calcium-rich supernova. That means the stuff our teeth and bones is made from is, essentially, the remains of dead stars that blew up a long time ago. These events are so few in number that we have never known what produced calcium-rich supernova. By observing what this star did in its final month before it reached its critical, we peered into a place previously unexplored, opening new avenues of study within transcendent science. An extremely bright event some 55 million light-years from Earth grabbed the attention of the international astronomy community in April 2019. Every single country with a prominent telescope turned to look at this object. Astronomers were so quick that many observed the supernova just 10 hours after the explosion. The explosion is trying to cool down, Raffaele Margutti from Northwestern University, and a senior author of the study, explained in the statement. It wants to give away its energy, and calcium emission is an efficient way to do that. As it turns out, the explosion spewed out an immense amount of calcium. It wasn't just calcium-rich, Margutti said. It was the richest of the rich. They caught the event just in time to conclude that it was the most calcium to have ever been observed to be emitted from just a single event. The luminosity tells us how much material the star shed and how close that material was to the star. Jacobson-Gallon explained. In this case, the star lost a very small amount of material right before it exploded. That material was still nearby. Explosions and mergers of stars are also known to create other heavy elements like gold and platinum. But the calcium has presented more of a mystery. That changed when a global team of almost 70 scientists from around the world collaborated after receiving a tip from an amateur astronomer. The study published Wednesday in the Astrophysical Journal. NASA's orbiting Neil Gerald Swift Observatory, the Lick Observatory in California, and the W.M. Keck Observatory in Hawaii, which researchers at Northwestern University can access remotely, all were turned toward the anomaly. They requested that Keck observe the event in optical light, while University of California Santa Barbara graduate student H.I. Hiramatsu used the Swift Observatory to observe it in X-ray and ultraviolet light. In fact, scientists had observed a calcium-rich supernova. The X-rays revealed intriguing new information about the explosion and the star itself before it exploded. The stars responsible for calcium-rich supernovae shed layers of material in the last months before explosion, Jacobson-Gallon said. The X-rays are the result of the explosion violently colliding with this ejected material and stimulating a brilliant burst of high-energy photons. The heat and pressure of the explosion actually drives the chemical reaction that creates calcium, the researchers said. Usually, only a small amount of calcium is produced by each star as it burns through its supply of helium. However, when a calcium-rich supernova occurs, massive amounts of calcium are created and released in a matter of seconds. This occurs because the hot ball of material created by the explosion is trying to reach an equilibrium with its environment. The Hubble Space Telescope has observed this galaxy for the last 25 years, but never actually registered the particular star that caused this calcium-rich explosion. That's likely because it was very faint, either a white dwarf, or a dead exploded core of a star, or a very low-mass star. So the next time you brush your teeth or look in the mirror, know that the calcium in you comes from a distant supernova explosion.